This is a key to topic 14, worksheet 2. And for the main part, in this case, you want to find where the function is increasing, decreasing, constant, and then some information about the relative max, relative min. Okay, so when looking at number 1, notice you have this continuous function. All right, so this is a continuous function. Notice that at no point do I have to lift my pencil to get to the other part of the graph. It's just continuous. That's what we mean by continuous. So I can easily draw this without lifting my point. And so notice I remember when reading a graph, you always go from left to right. So when I go from left to right, notice I'm going to start here, the arrow. These are arrows here. I'm going to start here, and then you go from left to right. So notice as I go from left to right, I want you to notice when answering increasing, decreasing, or constant, you're looking at the y values. So notice that these y values are increasing. See, my y value here is getting bigger, it's getting bigger, it's getting bigger. Then all of a sudden, my y values are decreasing. See, they're getting smaller and smaller and smaller. Then all of a sudden, my y values are increasing. Okay? So increasing, decreasing, increasing. At no place did you hear me say constant. So right away, I know that for constant, you would say nowhere. So this function's constant nowhere. Now, here's what some students like to do. So I'm going to go ahead and increase the size of this so you can easily see what's happening. So, and that's about all as I can go. All right, so what they're going to do is sometimes they'll use a color to help them. So from negative infinity to this y value here, I'm sorry, to this x value, from negative infinity to this x value, my y values are increasing. Okay, so I'm increasing from negative infinity all the way to -2. Then from -2, notice what's happening to your y values. My y values are decreasing. So from -2 to +2, from -2 to +2, my y values are decreasing. And then from 2 to infinity, my y values are increasing. So when you answer this part here, when you answer increasing, decreasing, or constant, the interval, you're going to use intervals, the interval will be based on your x-axis. Okay? So what's happening to the y values? What's happening to the y values in that part of the domain? So from negative infinity to -2, my y values are increasing. So you're going to say negative infinity to 2. And just to remind you, for increasing, decreasing, constant, it's always parentheses. For us right now, for the part of the course that we're in right now, the only time you're going to worry about bracket is when we're talking about domain or range. All right, but for increasing, decreasing, constant, it's always going to be parentheses. And then from -2 to +2, your y values are decreasing. So from -2 to +2, your y values are decreasing. And then from 2 to infinity, your y values are increasing. So 2 to infinity. So there are two intervals. There are two parts of the x-axis, where your y values are increasing, and then only one part of the x-axis where your y values are decreasing, where your function is increasing, decreasing, and constant. Okay? All right. So sometimes it does help, though, to kind of use a color to help you break down the x-axis into those intervals where your y values are increasing, your y values are decreasing, and your y values are constant. Okay, part D. Now notice that when I read this graph, I said that this function is increasing, then all of a sudden it's decreasing, right? So notice that this is a high point right here. So we're going to call this a local max. Local max. So that's a local max. Increase, decrease. Here all of a sudden I go from decrease to increase. See that right here? So that's called this point here is called a local minimum. Okay? either the word local or relative. So you'll hear both of those words. So in my math lab, you may have assignments that use the word local. You may have assignments that use the word relative. They mean the same thing, okay? Relative. So within that relative position here, this is a high point. Within this relative local area here, it's a minimum. All right? Okay. Now, this is what it says. At what values of x is f of x? Now remember, f of x means y. So what values of x is y a relative max? So remember we said this was a relative local max, this was a relative local min. So this is a max, right? So if I label that point, and it may be a good idea to do that, if I label that point, that's the point negative 2, 16. Negative 2, 16. If I label this point here, if I label that point, that's the point 2, negative 16. 2, negative 16. It helps if you do that. So let's talk about the maximum now. At what value of x is y a relative max? Okay, so y is a relative max when x is negative 2. So you're going to say x equal negative 2. Oops, sorry, wrong place. Negative 2. And then what is that relative maximum? So the relative maximum is that y value. So that's, when we say that, that means the y value. Make sure you understand that's the y value that goes there. So the y value is 16. Okay? But then we do the same thing with this one. So at what values of x is y, f(x) is y, a relative or local minimum? So that's where I have a relative local minimum. So the x value is 2. So that's 2 here. So 2, negative 16. So the x value is 2. Then the relative minimum, that low y value, relative minimum is the y value, that low y value, that lowest y value is is negative 16. Negative 16. All right, so that was number 1. Okay, let's go to number 2. Number 2, again, increasing, decreasing, constant. So again, let's use a color for this. So I want you to notice as this is a all of those are closed circles, by the way. They're all closed circles. And so notice that as I go from left to right, always go from left to right, my y values are increasing. All right, so they're increasing. So see, this is an arrow here. So from negative infinity all the way to this x value right here, which is negative 2, my y values, my function, my y values, remember y value f of x, my function is increasing. Then from here to here, so in this little interval here, my y values are decreasing. And then from here to here, my y values are constant. See, all these y values are the same. They're all negative 1. Negative 1, negative 1, negative 1, negative 1. So they're constant. And then over here, from 2 to 4, my y values are increasing. And then you see this arrow. So from 4 to infinity, my y values are decreasing. Okay, so notice I'm going along my x-axis. So when answering these, you're putting the part of the domain that goes here. So from increasing, your function is increasing from negative infinity to negative 2. They're also increasing here, right? So that's from 2 to 4. So you have increasing twice. So that's going to go here. So you're going to say, parentheses, negative infinity. And remember, when we talk about increasing, decreasing, or constant, it's always parentheses. So from negative infinity to negative 2, my y values are increasing. And then the part of the domain that's also increasing will be from where the y values is increasing will be from 2 to 4. Okay? So from negative infinity to negative 2, you can see it here, your y values are increasing. Okay, so that's negative 2 right here. From positive 2 to positive 4, your y values are increasing. Okay, so let's talk about where the y values are decreasing. So remember, we're talking about y values here, y values. So where are the y values increasing? Where are the y values decreasing? Where are the y values constant? And then the intervals that go here are your x values, the part of the domain that corresponds to it. So notice that from -2 to -1, your y values are decreasing. So from -2 to -1. They are also decreasing from, this is 1 here, I'm sorry, that's 4. From 4 all the way to infinity. So from 4 to infinity, your y values are decreasing. 4 to infinity. And then they're constant at only one interval, and that's from -1 right here, -1 all the way to +2. So from -1 to +2. Okay? All right, now let's talk about the maximum minimum. So notice that, let's listen carefully, as I increase, as my function's increasing, all of a sudden it's decreasing. So this right here will be a relative max. I'm going from increase to decrease. Then notice though, see right here, remember you get a relative max, relative min whenever you go from increasing to decreasing. I'm sorry, relative max, excuse me, you go from increasing to decreasing. Relative min when you go from increasing to decreasing to increasing. Decreasing to increasing, relative min. So notice that you don't, in some textbooks, this would not be considered a relative min because you have all these constants right here. All right, so that's not considered relative min. So that I didn't even ask for it. All I asked for was relative max, and there are two places, here and here. So I'm going from increasing to decreasing. So this is also a relative max. Okay, so let's answer the question. At what values of x is y a relative max? So this point here, is -2, 2. -2, 2. And this point here is 4, 3. 4, 3. That's 4, that's 3. So at what values of x is y relative max? So y is a relative max here and here. So that'll be x equal -2 and x equal 4. So x equal -2, 4. What is r the relative max? That's the y value. So that'll be 2 and 3. 2 and 3. Okay? All right, so let's look at this one. So now here they want to know, what is the y value when x is 1? So when x is 1, see here's x is 1, right? This is the point that corresponds to that. So when x is 1, my y value is -1. So the answer is -1. What's the y value when x is 3? So x is 3 here, right here. That's when x is 3. This for some students a little bit harder because it crosses the x-axis there. So remember, that's the x-intercept, crosses the x-axis. So when x is 3, the y value is 0. So the answer is 0. When x is 3, the y value is 0. Okay? All right, so that is the key to topic, okay, so that's the key to topic 14, worksheet